Okay, we want to determine the unstressed length of the spring AC. So essentially what you have is you have a cable here with the length is also known. That length here is 2 feet, and then you have a force with P, and the magnitude is known as 80 pounds. So what you see on the figure is the equilibrium condition when you have the force as 80. Now originally this whole thing would have been unstressed. The spring would be a different length than what's shown on this diagram. So the current length is LAC, but this is really the original length which we're looking for, plus whatever the stretching caused by this force P. So you have delta plus the elongation. So your current length, which is AC, is really the sum of the original length of the spring plus whatever elongation is caused in the spring as a result of the force P, which is 80 pounds. So if I want to find this, then we would need the current length, then we would also need the elongation in the spring. Now we know the what we call the spring stiffness, which means your delta elongation is really the force in the spring, whatever is the force in the spring, that, and divided by the stiffness of the spring. So to actually get the solution we're looking for in this problem, we need the current length. Then since that's known, we need the current force. That means you need the force in the spring under that loading, and then you need the length. Now it's not hard to find those if you look at the trig, and if I look at the triangle by itself, then this length is 4 feet, this length is 2 feet, the angle between those two is 60, where this point being A, this point being B, and this point being C. So if I need AC, or the length of AC, all we have to do is use law of cosine. So according to the law, the length AC squared is going to be AB squared plus BC squared minus 2AB BC cosine of the angle between those two, which in this case happened to be 60. So you can make the substitutions. See, AB is 2 square, BC is 4 square, minus 2, 4, 2 cosine 60. So that's 16 plus 420 minus 8 will be 12. Your length AC will be square root 12 feet. So that's the length you're looking for. Then if I need to consider equilibrium, if I pick this point and if I draw the free body diagrams for point A, we need the force Fs. So we look at the free body diagram of point A.